Here's a short video providing some information about the Singapore Math program, in particular using bar models to represent and solve word problems. In general, there are only two rules to using the bar model approach. The first is that bars are used to represent unknown quantities, and we use segments to represent known quantities, and they should be labeled. So, let's dive right in. How much water should be added to 6 liters of a 60% saline solution to reduce its concentration to 40%? Knowing that 60% of the container is salt, that means 40% of the container is currently water. Because this container is 6 liters at the moment, we can calculate the amounts of salt, 3.6 liters, to 2.4 liters of water. Now we're going to reduce the concentration by adding some water, represented by this bar. If we're trying to reduce the salt to 40%, this means that 60% will now be water. And notice I've broken this down into 40 plus 20% of water. That's because it will allow me to quickly fill in the measured amounts of water, 3.6 and 1.8 liters respectively. So in other words, our container is now holding 5.4 liters of water. Because we already knew 2.4 liters of water were in the container from the start, that means that 3 liters of water should be added to the solution. Let's try another one. Today, the sum of Mr. Belder's age and his son's age is 38 years old. 4 years ago, Mr. Belder was 5 times as old as his son. How old is Mr. Belder? To represent their ages 4 years ago, we can use 5 bars for Mr. Belder compared to 1 bar for his son. Moving forward in time, we add 4 years to Mr. Belder's age. And we add 4 years to his son's age. Altogether, their ages add up to 38 years old, making each bar worth 5 years. Hence, Mr. Belder is 29 years old. Shall we try one more? Kira and Manuelo started traveling at the same time from the same location, but in opposite directions. After 2 hours, they were 176 miles apart. If Kira's average speed was 2 miles per hour faster than Manuelo's, what was Kira's average speed? We can draw a representation of Kira and Manuelo traveling in opposite directions. And notice that because Kira is traveling a bit faster, we show her distance from the spot being just a bit longer. The total distance can be labeled 176. To represent Manuelo's and Kira's speed, we can use a bar and a bar with 2 attached, respectively. Because the travel time for the problem is 2 hours, the distance Manuelo travels can be represented by 2 bars. Likewise, Kira's distance is 2 copies of the bar and segment. That means each bar is worth 43, meaning Kira's average speed would be 45 miles per hour. The end.